my class on fundamentals of electrical engineering. We are now on module 4 where we are discussing signals and systems. Okay. So we were talking about, or we were giving some introductory materials to continuous time systems and discrete time systems, especially linear time invariant systems. So in the previous session, though we had discussed some kinds of classifications for systems, which included linear and nonlinear, time invariant and time varying systems. We also talked about causal systems, which are going to be the systems that we will discuss all through engineering, because all real systems happen to be causal in nature. Okay, so in this session we might go into some stable systems a little more, and also perhaps dynamic systems, because we have both static and dynamic systems. And as I said earlier, there are invertible systems, okay, and all those different other classifications which are of importance in the engineering domain. Okay, so here we are now looking at, we are going a little further into looking at linear time invariant systems. So especially of the dynamic nature, as also some of the signals, okay, how signal structures can be built up, etc. Because such that these foundation materials you can use in the subsequent sessions, not just in signals as system, but also in other engineering portions. Okay, so let's look at the first question. Let a causal linear time invariant system. By now we know what are causal systems, okay, which need a cause to have an output, okay, or in other words, the output will not start so long as the input is not applied. So the input has to be applied at t equal to 0, okay, or a little before, such that you can have an output from the system. So a causal system, linear systems are those that convert directly from the input to the output. And we also have time invariant systems, wherein you can have the same time stamp as even if you have even if you delay the system. Okay, so these are some of the governing aspects with respect to identifying systems. And we also have governing equations for the dynamic systems. They are differential in nature. For static systems, you can have algebraic equations. Okay, so dynamic systems are identifiable by the differential equations. Okay, so they are linear because we don't have any powers for the differentials. Okay, and they also have constant coefficients because they are linear time invariant systems. Because time invariance means that you can have only constants. You can neither have functions of time nor functions of the dependent variable. Okay, so you will see that there are two types of variables here. One is the output variable identified by yt, and the input variable is identified by xt. They are variables, but they are dependent on time. Okay, time happens to be the independent variables for independent variable all the while for the dynamic systems. Okay, so we have, so in that context, the differential equation is explained as yt is equal to 1 by 4 divided by dt is equal to 2xt. Okay, so this immediately you should change into the format which is most applicable for transforming and solving any problem, which is going to be dy by dt plus k into yt is equal to c into xt, or in other words, it is the same as equal to dy by dt plus 4yt is equal to 8xt. Okay, so where xt and yt are the input and output respectively, it's impulse responses. So impulse response will be always given by ys by xs, okay, in Laplace domain, and then you have got to take its Laplace inverse. Okay, on the other hand, in z domain or for discrete time systems, it will be yz by xz, and then you can take the z inverse. Okay, it's also applicable to Fourier transforms, where you have yj omega by xj omega, and then and Fourier inverse. Okay, so here we have ys by xs. For getting ys by xs, as was mentioned earlier, the format that we saw right now is easily transformable into the Laplace domain as equal to ys plus 4 s ys, or ys s plus 4 into ys is equal to 8xs. Okay, so ys is equal to ys by xs is equal to, which is hs is equal to 8 by s plus 4, which is easily Laplace inversible to 8 into e raised to minus 4t. Okay, so we are from amongst the four answers, option D is absolutely right, and it is a causal system, so it starts only at t equal to 0, or signified by 8 into e raised to minus 4t ut. Okay, ut is telling us that the right side window is open. Okay, Second problem, consider a causal linear time invariant system characterized by the differential equation dy by dt plus 1 by 6 yt is equal to 3xt. So immediately s plus 1 by 6 ys is equal to 3xs, or ys is equal to 3xs divided by s plus 1 by 6, or e raised to minus 1 by 6 t is going to be one of the quantities which is going to appear in the output, or this is what is called as the zero input response. Without even any input, the system response, and that is given by e raised to minus 1 by 60. Okay, so that should immediately be in your mind. Okay, the response of the system to the input. So now the input is also there. It's given by xt is equal to 3 into e raised to minus t by 3 ut. So there will be two responses now. One will be dependent on e raised to minus t by 3, and other will be dependent on e raised to minus 1 by 60. Okay, so this is what we need to remember. Okay, where ut denotes the unit step function is. So the response is required, or in other words, A, B, C, D refer to the responses. Okay, so the response will, as I said earlier, will have both the components e raised to minus 1 by 6 t as also e raised to minus 1 by 3 t. So option A and B are rejected because they have only one of them. Okay, and option C and D, we have a good one where we have 54 e raised to minus t by 6 ut minus 54 e raised to minus t by 3 ut. Why? Because I am suggesting a different way of doing this problem. Okay, of course you can do it in the conventional manner as well, because dy by dt is now given by 3xt, or 3 into 3 e raised to minus t by 3 ut, or 9 e raised to minus t3 minus yt by 6. So yt by 6 is very simple, because yt of the answers given, if you opt for option D, dividing it by 6 gives you 9 e raised to minus t by 6 ut minus 9 e raised to minus t by 3 ut. So if you take it to the other side, okay, with this change of sign, because 3xt minus 1 by 6 yt will now become the same as equal to, if you take the differential of this 54 or D, you see that it is the same as equal to, when you differentiate it, minus 1 by 6 is going to be multiplied to 54. So it is going to be the same as equal to minus 9, as we got on the right hand side. And then when you differentiate minus 54 e raised to minus t by 3 with respect to time, you see that now it's going to be 54 divided by 3. Okay, so because minus and minus cancel, so that's going to give you just as we got in the earlier case, that is equal to 18, okay, because we had taken it to the other side, and so we had so we see that this is going to be the correct answer. What I'm trying to say in this particular problem is that it is not just the substitution and doing the problem method that I'm projecting. I'm trying to tell you that you have to focus on both aspects. That is, in the output there are two components. One is the input as such with all its weight, and that's why we are using the fact that dy by dt, okay, that's the change in the output is a consequence of both aspects. That is, one is of course the input is there, that is 3xt, or 3 into 3, 9 e raised to minus t by 3 ut is also there. At the same time, 1/6 of the output is also getting reflected in the change. Okay, so 1/6 is in the last option. It seems to be good because you are having 9 of each, 9 of e raised to minus t by 6 ut, as also 9 of e raised to minus t by 3 ut, with a change in sign, such that in total you are going to have 18 of e raised to minus t by 3 and 9 of e raised to minus t by 6, with the negative sign on the right hand side as dy by dt. So now it's easily fixable. That is, it is easily relatable, or I don't know what words to use, but then I hope dy by dt is now easily seen as equal to having a negative component of minus 1 by 6 into 54 for e raised to minus t by 6, as we saw just now, and there's going to be a positive version because minus 1 by 3 into 54 is going to give us 18, where we are having both options, that is the 3 into xt as also 1/6 of 54 e raised to minus t by 3, adding together to give us 18. Okay, so this is another, I don't think it is the roundabout way of doing a problem. It is an easy way of doing the problem wherein you have the intuitions with you. Okay, so moving to the third problem. Here we are given the response ht of a linear time invariant system to an impulse delta t. Okay, and the initially relaxed condition is ht is equal to, it has two components, e raised to minus t and e raised to minus 2t both positive. Okay, so two exponentials both are decaying or the decaying nature. Okay, so this if you can visualize, then the rest comes easily. So you have two exponentials added together as the impulse response. Okay, or what is inside the system is giving rise to such an impulse, such a response. Okay, there is also the impulse. There is also an input, the response of the system for a unit step input. So there are two types of responses. One is going to be what is inherent in the system, and other is going to be input initiated. Okay, so we have input is ut, which is the integrated version of the impulse. So the response can also be integrated. That is the zero input response of e raised to minus t and e raised to minus 2t when integrated give us minus e raised to minus t and minus 1 by minus or minus 1 by 2 or minus 0.5 e raised to minus 2t. Okay, from all the options we have only C giving these two quantities, that is minus e raised to minus t and e raised to minus 0.5 e raised to minus 2t as the contributions from the state of the system. Okay, now for the input it is actually activating both 1 by s plus 1 or else we are having two, that is here we are putting together ys into xs. Okay, sorry, by xs into hs. Okay, so xs is 1 by s and hs is equal to 1 by s plus 1 plus 1 by s plus 2. Okay, so if you multiply 1 by s to both the terms, you're having 1 by s into 1 by s plus 1 plus 1 by s into 1 by s plus 2. Okay, so both these terms give you a residue for 1 by s. Okay, so that is exactly what is going to be the coefficient for that is going to be the component that is going to give us the input initiated contribution to the output. Okay, so 1 by s by into 1 by s plus 1. If you remove s and substitute for s is equal to 0, that's giving you 1. Okay, and when you remove s from 1 by s by s plus 2 and put s is equal to 0, then you're getting it as half. So 1 plus half is equal to 1.5. Okay, so all understood materials are being converted into easy way of doing the problems, in the sense that there are both the contributions appearing in the input initiated come the internal energy initiated response, wherein the since the impulse response is e raised to minus t plus e raised to minus 2t, the unit step input response would be their integrated versions. There would also be a contribution from the input as given by 1 by s into 1 by s plus 1 plus 1 by s into 1 plus s plus 2, of which the residue for 1 by s alone need to be taken into consideration. Okay, there are other methods also, but this seems to be an easy method for doing the problem. Moreover, since you need not calculate the 1.5 component at all. Okay, because the rest has already been computed. And thirdly, there is only one answer which tells us the intuitive nature of the solution, in the sense that there should be a response for the input as well. It should not entirely be from the internal energy only. So you should have, this A is also okay. You are having ut there. Okay, so moving on to fourth problem, the symbols A and T represent positive quantities and ut is the unit step function. Which one of the following impulse response is not the output of a causal? Causal, we know, that is, it should be caused. That is, the output should be caused. It should not originate on its own. Or in other words, there must be something that is happening which is giving rise to an output. Okay, linear time invariant system. We discussed only linear time invariant systems here. So we are having first option e raised to alpha t ut. Of course, it has been caused. That is, this is definitely an impulse response. We were already given a problem there. E raised to t ut starts at t equal to 0, so it's okay. Okay, so e raised to minus a t plus t ut is also e raised to minus a t ut multiplied by a value as given by e raised to minus a capital T. Okay, so e raised to minus, because a and t are values, e raised to minus a t becomes a particular solid numerical value. Okay, but 1 plus e raised to minus a t ut, one has originated on its own. Okay, it does not have an initiation, or in other words, that is not going to be a causal system. That is not indicative of a causal system, because one does not have ut with it. Okay, so moving on to the fourth one also, we see that e raised to minus a t ut now has a coefficient as given by e raised to plus A capital T. Okay, so which is just a numerical value. So everything except C happens to be applicable or acceptable as impulse responses, but C is not. Okay, and that's the correct answer. Okay. Fifth one, which one of the following statements is not true? Just like the earlier problem, what is not true is asked for a continuous time. If we were doing only continuous time so far, causal, yes, causal causal includes all the engineering as also real systems, and stable. Okay, real systems are stable. You can't have unstable systems except for just for evaluating their functionalities. Okay, LTA systems. Okay, so all the poles of the system must lie on the left side of the j omega axis. This is the rule for having stable systems. Okay, so that's acceptable. So, okay, but of course all poles or all eigenvalues or all roots of the characteristic equation are all the same. Okay, they all should lie on the left side of the j omega axis. Okay, so option A and option D are talking about the same thing, but option B is talking about zeros which have no restrictions. So that's also true. Okay, the only option which is not at all acceptable is all the poles must lie within the absolute value of S remaining equal to 1. Okay, this is not true because this is applicable actually to the the Z transform wherein we talk about the unit circle. Okay, so that's rejected and that's accepted as an answer. Okay, so let's move to a signal here. The function shown in the figure can be represented as. Okay, so we are given several options. Don't look at the options if they appear to be too complicated. You start off from the beginning and then you see what matches. Okay, like for instance in this representative of the signal, we see that as t goes along, we start the signal at t equal to 0, and what happens, there's a pulse. And how do you describe a pulse? It's always going to be ut minus a capital T here. Okay, so do we have something that starts off like that? Option A and option C seem to be start off like that. The rest all happen to be describing something else. So we watch out for A and C. Okay. Now what do we have at capital T? We start a slope there. Okay. And what is the slope of it? It's going to be equal to 1 by T. Okay. The height is 1 and the width is going to be 2t minus t of t, so 1 by t. So we will have a slope. It's a positive slope, so 1 by t. Okay, and where does it start? It starts at t. So how do you indicate the starting point? Ut minus capital T. So what comes next? Ut minus t is applicable only for option A. Okay, so we start. So for the time being we reject C and we just see if option A is right. Okay, so this is the way to solve the problem. Okay, so you see ut minus t, we have 1 by t plus 1 by t or positive slope, and then the intercept as also the expression of mx plus c is there in t minus t. Okay, so it proceeds further, but at t equal to 2t it comes to a halt because now it has to level off. Okay, from a positive slope it has to come down to a zero slope. Okay, or you have to have a negative slope there, so minus should be there, and it should start at 2t, so ut minus 2t should be there. So minus and ut 2 minus 2t is also applicable. The slope is again, you have to remove the entire slope, so you have to have 1 by t. On the other hand, if you have to want to dip it, then it has to be more than 1 by t. Okay, it should be 2 by t or something like that. Okay, so you have minus 1 by t, and the slope is given by minus 1 by t as before because it is leveling off. Okay, and you also have what is called as the expression for the line as given by t minus 2t. Okay, that is the sloping line for the ramping. Okay, so t minus 2t, why? Because the intercept is given by this. Okay, so as simple as that. So we have option A fully explaining the waveform as ut minus ut minus t plus 1 by t into t minus t ut minus t minus 1 by t into t minus 2t ut minus 2t, explaining the fact that now the signal is going to proceed indefinitely or infinitely to the as t goes on. Okay, so there's no stop to it. Okay, unlike in this problem wherein we are given the signal and we are supposed to find the signal energy of the continuous time signal. Okay, so here we don't have the option of seeing something, but we are going to see something by drawing whatever we have. Okay, so we go step by step. What do we know? We know that we have to find out the signal energy. So how do you find the signal energy? You have to take it square. Okay, so instead of taking the square, we can always find the area of the content in or any bubble that you get in the in the diagram once you draw it with respect to time, okay, because that's exactly what is energy. Power into time is going to be energy, okay. So power, you'll take the square, and then you'll have to divide by the base, okay. Here you don't, you just find the area, okay. So what do you have here? T minus 1 into ut minus 1. What does it mean? It starts at t equal to 1, and it has a slope equal to 1, okay. And the intercept is already included in t minus 1, so you have a slope as equal to 1. So if it goes from 1 with a slope of 1 at t equal to 2, it will reach 1, the magnitude will reach 1, okay. And then you are having a leveling off because you are having a negative slope, okay. Slope is the same, so minus t minus 2, it starts at t equal to 2, so t minus 2 to ut minus 2. The picture as also the picture of the line, or the line as also the intercept is included in t minus 2, okay. And then now we are going to have a negative slope, so again, so now it's going to dip, okay. So minus, again the slope is equal to 1, and you are having, it starts at t equal to 3, so t minus 3 into t minus 3, okay. And then when it reaches 4, because the slope is all equal to 1, be it positive or negative, when it reaches 4, now it would have continued, except for the fact that now we are going to level it off from the bottom, or you're going to have a positive slope as given by 1, okay. The line is given by t minus 4, and the starting point is given by ut minus 4, so it stops there. And then you are going to have 0 as the what is going to be the value of xt from t equal to 4, okay. So now we have a diagram, we have a small bubble, so we can find out its area by dividing it into 3 components, okay. Of course, when we require x square, so you multiply you square all the amplitudes, so 1 becomes 1 both for the top of the triangle as also for the top of the squares in between, but the sloping lines become parabolic in nature, so we have to find out 1/3 the area there, so 1 by 3 into 1 is going to be the 1 by 3 into 1 is going to be the and then you multiply by then there are 2 triangles, so 2 into 1 by 3 plus 1 is going to be the area of the square, so all together you realize that it's the same as equal to 5 by 3. So as simple as that. I hope this problem is also well understood, just like the earlier problems wherein we tried to use easy methods all through, but then the easy methods can help you to do the problems very quickly, so long as you understand the underlying concepts, okay, whatever was talked about in this session all through, okay. So thank you.